In the previous video, as you may recall, I used 828 here, 828, and then when I added the syscall, it created an error. Okay, so why was I using 828? Well, because the book that I'm drawing from, Commodore 64 Assembly Language Programming from Hayden Books, used 828. And as I have demonstrated, it worked just fine until I added the syscall in there, right? Okay, now I had erroneously said that this was the beginning of user memory. That is not quite correct. If we go over here to the C64 Programmer's Reference Manual, which you can find online in a variety of places, here is the map of the memory locations in the Commodore 64. Here we have 1024 to 2039 screen memory, which we'll be using in a moment. But here's the bit we're interested in. Here it says start of memory to memory used by the operating system up to 1023. So you could see where if I used 828, it could actually create a conflict with the operating system. So if we go down here, it says this is your memory from 2048 to 4959. So you have ample memory space available here to play around with. And when I used an arbitrary value of hexadecimal 1000, it fell well within the parameters of this. So just taking that on board for a moment, 2048, if that's the start of memory, okay, I'm going to just put 2048 here, and then that makes this syscall obsolete, so I'm going to add a new one, generate syscall. 2048 would be 800 in hexadecimal. Okay, so now if I were to launch that, it gives me an error here, memory overwrite, but it's going to go ahead and launch the program anyways and give me another error. Okay, so reason for that, see if I hold my mouse over here, it tells you uh, the value in binary, octal, decimal, and hexadecimal. And let me do that one more time. Decimal, it's 2049. So you could see where if I'm using 2048 here, where there could be a memory conflict, right? Here it says memory override detected. So fortunately, CBM Studio has the foresight to tell us what the error is instead of just the generic error from the C64. Okay. So therefore, if this is overlapping a little, let's clean that up. Let me just count the bytes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 bytes are being used here. So then in theory, if I added 16 to this value, which would make it 2064, and then let me reset my syscall again. 2064 is 810 in hexadecimal. So that means, I could also go $810 here, and it's the same as 2064 here. You see the syscall tells you what the value is there, but 2064, good enough. So now if I launch that, we are free and clear, and there's no conflict with the syscall and my declared start of memory.